Hard to believe it's day 17 already. Alright. Finally decode the Elves' message. Hi. How to use what appears to be a large ocean trench. Could the keys have fallen into it? The probe launcher, integer velocity, x forward, y up, down. Initial xy is 0, 10 would fire the probe straight up. Initial velocity like 10 would fire the probe forward at a slight downward angle. Probe's xy position starts at 0. We'll follow some trajectory, moving on steps. On each step, these changes occur. Probe's xy. Due to drag, the probe's x velocity changes by 1 toward the value 0. Due to gravity, the probe's y velocity decreases by 1. For the probe to successfully make it to the trench, probe must be on some trajectory, causes it to be within the target area after any step. The ring computer's already calculated the target area. So this is my puzzle input. Okay. By the way, using Visual Studio today. Oh, that font is way too small for you guys. There we go. That's better. Target area means you need to find initial xy velocity values such that after any step, the probe's x position is at least 20 and at most 30, and the probe's y position is at least minus 10 and at most minus 5. Given this target area, one initial velocity that can cause the probe to be within the target area after any step is 7, 2. In this diagram, S is the probe's initial position, 0, 0. X coordinate increases to the right, y coordinate increases upward. 6, 3 also works. 9, 0 also works. One initial velocity that doesn't cause the probe to be within the target range is 17, 4. 17, negative 4. Okay. If you're going to fire a highly scientific probe out of a super cool probe launcher, you might as well do it with style. How high can you make the probe go while still reaching the target area? So that's kind of interesting. So you want it to go high, which means you have to start with a positive y, right? 6, 9. What is that, 6, 9? Causing the probe to reach a maximum y of 45. Any higher initial y velocity causes the probe to overshoot the target area entirely. The highest y position it reaches. Well, that's interesting, isn't it? Okay, well, I guess we'll parse the data. Right, so target area colon. So you'll be at, we'll start at position, where's my cursor position? Wow, is there no, cursor position on screen anymore? What am I missing here? There it is. CH14LN1, there we go. Okay. So we'll start at 13, apparently. We're going to do x equals blah, y equals blah. All right, so we're going to go ahead and parse the line. And we'll just do first. And out of this, we want what kind of a range, right? Right. So let's do a record. Actually, if we're going to do a record, we have to do it at the bottom. Record range. And then we'll say int min x, int max x, and int min y, int max y. All right, and so we're going to return a range from parse line. All right. Pieces are going to be line sub 13 on split on comma, right? On comma space Sure, comma space. And that, let's see, x range is going to be pieces sub 0 split on equals, right? And then we'll take the first piece of that and then split it again on double dots. And then the y range, and we'll select int parse. So that should get us, yeah, a couple of ints. Sure, toList, just so we can do it easy. Return new range, x range 0, x range 1, y range 0, y range 1. And the data looks like -10 to -5. That's kind of interesting. We want them, let's go ahead and sort them. All right. So our x range is 2030. And our y range is 2030. How about we do that? That, please. And our y range is, come on. Come on. Okay. Y. What are you waiting for? Wow. I didn't think Visual Studio could be worse than OmniSharp, but I guess I was wrong. Okay, fine. So our data is a range. So we know sort of we're looking to get high up. Right, we know, what we really want to do is, I think, run the variables for x. Yeah, we want to run the variables for x such that we can stop after x is, you know, this big. Right, because obviously if we shoot out at 20 right away, that's not even going to be any good. In fact, we can probably cut it in half, realistically. Actually, what's our real data look like? Let's go get our real data. Yeah, that's not too bad. So that's the first way to restrain ourselves. So let's do that. Let's do that. X is 0. X is 0. Sure. X is less than, let's do, max x is data dot max x. Actually, I don't need to store that, right? So for each one of these x's, let's say highest y is going to be int min value to start, right? And then target x is a default int. Target y is a default int. Okay. So here, what we want to do is we want to run this. How do we know when we're done? Right, we know we're done when either x is too far or y is too far. Or we've hit the target. And so for here, it's negative 10 to negative 5, negative 10, negative 9, negative 8, negative 7, negative 6, negative 5. So those are inclusive. So we have to remember to be inclusive. All right? And then we'll say y is 0. All right, and then we'll just say while true. Let's see. What is the best way to constrain y? Because we need a stopping point, right? Probably the constraint for y is if we miss the target, right? And we still hadn't hit it in the x direction, but we hit it, but we exceeded the target in the y direction, which they don't show here. But think about the more different version of this would be like if we went up and we went down and we went past here. When we still hadn't hit the x direction, but we had already exceeded it in the y direction, then we know we've gone too high. Going higher isn't going to help any, right? Because all that's going to do is push us further left, right? Because then we'll just do this instead. So that's how we'll know that we're done. Okay. We'll start with this. So each position, we need to know. So what we need is current x is x, right? And then current y is y. Or we call these start x and start y. That'd be a little bit better names, right? And then while current x is less than target x, well, no, less than data.min x, and current y is less than data.min y. So before we've failed or succeeded, right, we need current x all right, so let's see. Probe's x position. Oh, x position starts at 0 and 0. So this is wrong. My bad. This is supposed to be 0 and 0. Starts at 0, 0. On each step, it increases by its x velocity. It increases by its y velocity, but it also decreases x by 1 and y by 1. Increases by 1 if it's less. Oh, this is different. Okay. So the current x plus x, right? Current y. Let's see. We'll call this velocity x and velocity y. And then velocity y. All right. And then we need to say if x is greater than 0, so if current x is greater than 0, then current x minus minus, else current x plus plus, right? Increases by 1 if it's less than 0, does not change if it's already 0. Else if current x is less than 0, then it goes up 1. Okay. And then for y, always decreases by 1. Okay, so this should give us a potential hit. All right, so if this is a hit, that would mean current x is greater than or equal to data max x. Less than or equal to, sorry, less than or equal to. and current y is less than or equal to data.maxy. If that's true, then we have a hit. We'll say if max y is going to be int min value again, right? And then here we're basically going to say if current y is greater than max y, then max y is current y, right? And then here we'll say if max y is greater than the highest y, then we're going to say that highest y is max y, and target x is x, velocity x. Target y is velocity y. All right, so we also need to find a way to break out. And we're going to return the highest y. I don't actually think I need the target. In fact, I'm pretty sure I don't. So we also need to know what our breakout case is. So otherwise, if so we have broken one boundary but not both. So if the x is still less than data.minx, right? That means we have the situation of we're done. That means we need to break. Why are you out there? Right? I'll just leave that there. We don't need that, right? So that'll break out of this. Then that'll give us a new x. And then that will stop when we hit there. So let's start looking at how this works. Let's say tracking fellow x, fellow y. Here we'll say we have a hit at current x, current y, and then here we'll basically say console right line miss. All right. That's that. Wait a minute, that's that for. What am I missing here? Yeah, missing a curly brace. Okay, so you're upset because we didn't get the return, because the return actually goes there. Right? Let's see what happens. Minx. Okay, so everybody was a miss. That's bad. Let's see. It's all right. Current x, current y. Right. After that, we'll say console right. Okay. We literally don't ever track anything. I don't buy that. So current x, current y. Oh, this is a greater than, not a less than. Yeah, of course. Okay, nobody's moving anywhere. That's no good. So 0, 0 doesn't really work, does it? We'll say we need at least 1 on the Y. And obviously, it would be there. We have to start. Actually, x of 1 will never work either, right? Because then we never move right. Oh, what the hell is going on here? Velocity is x, starts at 1. Oh, this is max y. And this is min y. But that's not the problem. Okay, what's going on here? Yeah, I don't care about that. Alright, so we're going to track 1 by 1, right? 1 by 1. Okay, given 1 by 1, and max y is there. So current x is clearly less than the minimum x. Current y is clearly greater than the max y. So if current y is greater than our big max, so that'll put us at 0, right? So that puts us at 0. So now x is at 1, y is at 0. Oh, because that's actually okay. Oh, no, it's really not. Because this will drop us back. So do we have to start at 2? I mean, I feel like 0 is okay for x, but maybe we need 2 on the y side. But if we're at 0, then we know we're never gonna... Yeah, we know we can never make it. You have to be at least 1. But this is what's weird, like the rule that says due to drag, if the probe's x velocity changes by 1 towards the value 0, that is, it decreases when it's greater than 0. So basically, what is implied here is that if this ever hits 0, then we have to bail. Right? We just have to bail. Console right line terminal x velocity. Because we'll never go far enough to the right. We will have slowed down. Okay, well that's interesting. So 1, 2 is a terminal velocity. Where did this break? This break came out of here. Actually, we don't even need to say that. We can just break. Terminal x velocity. We're stuck. Okay. I'm a little confused. I want to stop this pretty quick. I'm a little confused exactly what's going on here. So we're tracking 2, 2, which gives us out to here, and then we stop. We don't say anything because we hit 20, right? Because we hit 20. 20, 20. So I think what that means is we just need to say we have a miss here, but then also a break. Like if we didn't get far enough there. Right, and all these are just going to 20. The problem with going up with y are we, like, am I missing something with y here? Maybe y needs to start at 0. Right. Is that math just wrong? It definitely looks different now. I feel like I did something wrong with my math before. But why am I allowed to do this so much? Maybe we should start. Oh. Let me run this again. Let me see if I'm really thinking about this the right way. So we start at 1, 0. That doesn't work. Because -5 is when we hit the edge of y. Do we get any hits in here? I'm a little confused. Also, when we get to 5, we stop. We stop having useful conversations. Why? What am I missing about this? Gotta be something I'm missing about this. Like, I don't think I'm correctly bailing out here when I should be. Right, so I hit 20. So for 5, 0, so what's happening here with 2 0s is that we get to 5, -5. And we're not far enough to the right. So it looks like my bailout condition is backwards. Is that right? So given the x on the y we have, we need a bailout here as well. What is the bailout? Let me run it again. All right, there's a bailout. There's got to be a bailout here. Also, why are you... Wait a minute. I'm missing something with this y condition here, right? Due to gravity, probe's y velocity increases by its y velocity. So here we go 7 and 2. 1, 2, 3, 4, 5, 6, and 2. All right, 1, 2, 3, 4, 5, 6, 7, and 2. Then we've got 1, 2, 3, 4, 5, 6, and 1. Oh, the velocity changes, not the position. Oh my goodness. I see. Yeah, so this loop is wrong. I understand what I'm doing now. So if the velocity is going to change, there's my start velocity x, there's my start velocity y. Okay, so x goes up by the velocity, y goes up by the velocity. Velo x is the start velocity x. Velo y is the start velocity y. So you're going to go up by velo x. You're going to go up by velo y. So we don't... This terminal velocity thing I'm not... Jesus. Don't care about, I don't think. All right, so if velocity y... Velocity x is greater than 0, then velocity x minus minus. Otherwise, velocity x is less than 0, velocity x plus plus, and then velocity y minus minus. Why is there so much weirdness there? Okay. So we know 7-2 should be a hit. So we end up at 7-2, and then 13-3. 13-3, 14, 15, 16, 17, 18, 3. Right? 19, 20, 21, 22, 2. And that's considered a miss. Oh, that's not a miss, though. We want to see if they go past it. And then we want to test it. Right. So current y is greater than or equal to max y data.max y, and you're less than or equal to the min y, then that's a hit. And then a break. Except that's not enough of a break, is it? I'm not sure about this check anymore. Like we can also say this, if the highest is equal to max y, then you can break again. Does that mean that means we had a hit? No. How do I get out of there? What is your problem? Sure. Wow, that just really went crazy, didn't it? So where's 7-2? Do we get a hit on 7-2? No, we're never getting out of 6. Yeah, so how do we know that we've gone too far? I think this needs to basically be that needs to be that. No, we're still not getting out of here, are we? All right, so 1 minus 10 means yeah. Obviously, this is never going to get us there, which means we should always start at 2, I think. I could be wrong. So these all bail out because we didn't get enough in the x, but we got too much in the y. Too much in the x and too much in the y should bail us out of here. So too much in the x and too much in the y. That's what that should be. Oh, wait a minute. Should be not enough x. No, that was right. Not enough x, too much y. really not... Yeah, I'm really not hitting it here, but let me see. So 1 means we didn't get far enough to the right. These, this is 20 to 30, right? So 30 means we got too far to the right and not enough down. All right, so for a given x, if we didn't get far enough, but we exceeded x, that's when we need to bail. That's why this is bailing here. And why we don't come back for 1 again. So here, this is a mistake. Why did we bail out here? Oh, that's probably just because I did a straight up break here, right? The difference is we got too far in the x. We didn't get far enough in the x. We're getting far enough, so we want to keep going. Getting far enough on the x, so we want to keep going. So I'm back to this again. We're not hitting anywhere on 6. Is that wrong? So I got a 7-2. See, 6-3 we're supposed to hit. Right, we're supposed to hit right there. 21 and -9. That's a hit. So our hit test is wrong. Okay. So if the current x is greater than or equal to the min, and the current x is less than or equal to the max, and the current y is greater than or equal to the min, less than or equal to the max. Is that the problem there? Six one hits there. Except we can't stop there, can we? So we did get a hit. We don't want to stop. Yeah, we don't want to stop. I think it was a mistake to stop here. Yeah? Right? We just want another one. This break breaks that while, this continue continues that. God, I hate when it does that. It's just dumb. Okay, so 6-1 hits with a height of 1, 6-2 hits with a height of 3, 6-3 hits with a height of 6, 6-4 hits with a height of 10, 15, 21 with a height of 28, with a height of 36. And then when we miss here, right. The exit scenario here is max x, not min x. Dumb. Okay. No, so this is wrong. -10. Here's my first question. Like, should this be starting at 1? Is that going to get us better exit conditions? One, 3, 6, 10, 15, 21, 28, 36, and then a miss. And then as soon as we miss, then we move on. All right, 1, 3, 6, 10, 15, 21. More of this with 7? How could this be exactly the same? I guess it could be, because we're just shifting it right by 1. Right, because we had a 25, -5, 28, -7, 28, 20. Yeah, because at some point we stop moving to the right because of the x velocity. So here at 8, go with 30, -5. I'm clearly I don't have all the exit criteria in my head yet. It would be 30. So when we come out of this, our 2 exit criteria should be if or current y is greater than data. Whoops, that should be max y, by the way. No, that's right, min y, max y. So our 2 exit criteria are off the 2 edges, I think. So if you undershoot on the x side and overshoot on the y side, or you overshoot on the y side and undershoot on the x side, Undershoot on the y side. Undershoot on the y side, then it should be overshoot on the x side. Or you overshoot on the y side and undershoot on the x side. Oh, that's obviously wrong too. So we get to 1, negative 14, right? That's an overshoot on the x side. Oh, you know what? I probably have these wrong in my head. So an overshoot would be, this is an overshoot. That's an overshoot, which means this needs to be an undershoot. So the undershoot would be current x less than min x. So on the other side, this would be an undershoot, and this needs to be an overshoot. All right, so an undershoot for y means that we still haven't hit the top of it, but we went past the bottom of it. So that stops this and this and this and this and this. And okay, so these all hit like they should. 36, this misses, and we just stop. We stop here. Why do we stop here? Maybe we just stop when we miss. Let me think about this. So there's no point in going up in height. If we miss on the x side. Maybe that is the right answer. Right? So 36 is the tallest height we saw. Well, you say 45 because of 6'9". 6'9" is 21 minus... Oh, why is 21 minus 10 a miss? 21 minus 10 is a hit. Did I do the... So 21 will be in between 20 and 30. So current x, 21, it will be greater than or equal to the min, will be less than or equal to the max. Current y is negative 10. That will be greater than or equal to the min and less than or equal to the max. Because it's negative 10. Yeah, I don't understand this. Why doesn't this hit this condition? So the condition is going to be start velocity x is 9? No, it's 6. And start velocity y is 9. Don't care. Okay. Whatever. So the current x so 6'9". So the current x, so this is the first position, right? So we get 6, 9, we get 11, 17, we get 15, 24, we get 18, 30. $20.35, $21.39, and then 21 sticks. That goes all the way up to 45. Now this should come down to -10, right? So what is current? Am I testing this too soon? Testing it too soon, aren't I? Dear Lord. How could I? Okay, theory. That's doing our thing. Where's our real data? Here's our real data. Okay, now let's... Yeah, whatever. Leave the debugs in there. The best height is 6? Wow, that seems suspiciously wrong. Yeah, I didn't think so. So we don't know what our target is, because I don't remember. Target is -101 to -57. On our X is 257 to 286. So we start hitting at 25. Height of 3, height of 1, height of 3, height of 6. And then we miss. Keep hitting with 1, 3, 6, and then missing. 1 miss, 1 miss, 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 all the way down until we just constantly miss. Hmm. $25. Do we get a sticky? See, we don't even get sticky X here, do we? See, here we get 289, -68. 289, so that goes off the edge. But we're still in the middle, right? Which means adding more X isn't going to help. So that's okay that we bailed out there. $285. Height of 6. See, these heights aren't very high. And I wonder if we shouldn't... Like my initial thinking, and I still feel this way, which is we should only bail when we have stopped throwing it up high enough, when we're throwing it up so high that it can't possibly get over in time. But right now we're bailing on every miss. So let's go back to our old data. So I still kind of feel like if, let's see, current y is less than data min y, and current x is less than data min x, we should break. I still feel like that's the right answer. But it kills us over here. Like, we never stop checking for 6. There's another condition. 6-9 hits 45, 6-10 is a miss. This is a condition that we know 6, we sort of know 6 is terminal. Oh, we know it's terminal because our x velocity is 0. Maybe that's the answer. Right? If we have undershot and our velocity x is 0, then we should stop. Okay, so that helped us get out of 6. And 7. Then here on 8, we also need to say if we overshoot x, then our x is too big for this y. And adding more height isn't going to help. All right, so then we say, or current x greater than data max x. That's the other way to get out, right? Thought. Greater than or equal to, actually. Okay, or this is greater than or equal to this, and velocity x, and we're still going to the right. Okay. What happens if we do that, then? 1225. That's a more reasonable number to me. Oops. That's not it. Your answer is too low. If you're stuck, make sure you're using the full input data. There's also some general tips. About page. No, that's not going to be hints. We can ask for hints on the subreddit. 1225 is still low. It's interesting. So here we've reached terminal x velocity. So we bail. The first time we start hitting, is we're not done trying at 17 because we weren't at terminal velocity until 17.2. So we don't start hitting until, what, 23? So here we missed, and then presumably hit terminal velocity and terminal, yeah, so terminal velocity for 23 is 248, obviously, or terminal x point, I should say. Or I guess it's 255. I don't know. Oh no, we haven't hit terminal x here, right? We're not going up. Never mind. 6, 10, 15, 21, 28, 36, 45, 55, 66, 78, 91, 105, 120, 136. So this just continues to hit because of the 276. This continues to hit. All the way through. This hits a bunch. On the 24 we missed once. So this was our highest. Was 50. Because 50 was a miss. 49 was 1225. Funny thing is, we know, like, we don't have to run this whole thing, right? Like, I should be able to figure out which X's and which Y's hit. Actually, I don't think I care about, well, I do care about X's because they have to hit. But Y is uninfluenced by X, right? X position goes up by X velocity, Y position goes up by Y velocity. Due to drag, the X velocity changes by 1 towards the value of 0. If it's greater than 0, it goes down 1. If it's less than 0, it goes up 1. If it's less than 0, it goes up 1. That means our start position for X shouldn't be 0. Start velocity for X shouldn't be 0 or 1, right? It should be actually, that rule doesn't make any sense. If you start at 0, 0 and your target is always to the right, you're going to need right-hand acceleration. That's just all there is to it. If you start with a negative velocity, like let's say -1, right? That's not going to help. Those are never going to hit. Right? Because you're never going to make it to the right. Let's try negative data.maxx. My guess is none of those hit. Right, those all just continue to go backwards forever. Even you know, doing -2. So -2 gets me there, which makes me -1, which gets me there, which makes 0. So those will never work. So yeah, starting at 1 was correct. Yeah, I hate when it does that. And here we now Go ahead and print that. But here we know, like, we know that's a good time to break out. Because if we didn't hit, well, actually, we don't know that's a good time to break out. Don't be dumb about that. Oh. We don't start hitting until here. Which is coincidentally the first time I think we actually hit the 0 velocity, right? In a hit range. And then we continue to hit. Over and over again. So we know that 49 will get us 1225. That happens exactly once? But this is a miss. 276 minus 103. 276 minus 103. Yeah. Because the next one was negative 51 and it wasn't inside. So we bounced right over it. Is that... Except we shouldn't have bailed out yet. We might have more hits there. So this is our bailout. We might have more hits. How do we know when to stop, though? Can't just stop when we have one miss. How do we know when to stop? So this is at 23, right? Let's just start at 23 and never bail. So we know we hit with 49, we missed with 50, and we missed at 51, we missed at 52, 53, 54, 55. We hit with 56. 57, 58, 59. Wow. Let's not write that. When was the last time we hit? We hit with 50-50 at 100. Could that actually be our answer? I don't know the end condition. Maybe a fancy trick shot isn't the best idea after all. You only have one probe, so you better not miss. To get the best idea of what your options are for launching the probe, you need to find every initial velocity that causes the probe to eventually be within the target. For example, there are 112 different initial velocity values that meet this criteria. How many distinct initial velocity values cause the probe to be within the target after any step? Can't help but notice a bunch of negative Y's. Yeah. That's the first mistake we made. There's no negative Y's. The second mistake we made was we don't know what the end we still don't know what the end conditions are. All right, I'm going to take a look at 23. We'll start at 98. And we'll put these back in. See if I can identify. Actually, let's do like 95. Go to 105. So we hit at 100 with 50-50. And we miss 101. Is that a coincidence? $101 and $102? Seems weird that we end up at 0 here every time. This is our max X. 286. What happens if I go to 30? It's almost like it doesn't... Like the X and the Y can be treated separately. Except they really can't. Yeah, there's something I just don't understand about this problem. So, I've been at it for an hour and a half. So I think I'm going to take a break, which means I'm going to end the stream. See if I can sort of ponder it. Kind of like, see if some magical math thing comes into my head. I'll try Googling around for problems like this. See if there's an obvious solution that I just don't know because I don't have a degree in math. Cool. All right, well. Yeah, if I figure it out, maybe I'll throw the camera back on, but not likely. So, more likely, see you tomorrow.